Hello everybody, welcome back to our virtual classroom and a mini series on the power tool we call the circular saw. The first video is going to cover the parts and features of these two saws and how to make a simple cross cut. The second video is going to cover three different types of alternate cuts, which will be a bevel cut, a panel cut, and a plunge cut. The third video is going to cover maintenance tips like how to change a blade on this tool. So let's get right into it. To begin, there are two main types of circular saws. They basically do the same thing, they just are set up differently, the way they're constructed, which makes them operate differently. We're going to go over the direct drive circular saw and the worm drive circular saw. I'm going to start with the direct drive saw. The configuration of the direct drive saw is going to have a lot to do with the way the motor engages with the blade. As you can see here on this saw, there is a direct connection from the electric motor to the blade on the other side, and the motor is in direct line with that blade. This is going to make a big difference in the way this tool operates. The bottom line is this tool tends to be lighter in weight than its brother, big brother, the worm gear saw. The other thing is it tends to be a little more compact, and it does not offer, the trade-off is it doesn't offer as much power as the other saw, the worm gear saw that we'll talk about. One other disadvantage to this saw for a right-handed person is that when I'm using this saw, my blade is on the far side over here on my right side. So now I have to look through the saw to sight the edge of my blade. We're always sighting the blade edge when we're trying to keep this all lined with a mark to make a cut. So our sight line is very important. The more you use this tool, the more comfortable that becomes. But keep in mind that the process is looking through the saw to see the sight line. Next up, we have the worm gear. And this saw is a lot heavier. It's a lot more powerful. And the configuration of the motor goes like this. So we have a motor that runs from front to back, very heavy, powerful motor. And there is a gearbox that's going to make a right angle turn. Then the blade's going to turn here. So my blade is now on the left of my worm gear saw. If you can imagine, for a right-handed person that has to sight that blade every second the saw is moving, this is a much better situation to watch the leading edge of that blade. So this tends to be a very popular saw for carpentry for that reason. The extra weight of this saw also contributes to the extra power of it. The motor's bigger, it can deliver a lot more horsepower to the cut, which means we can cut through a lot more materials, thicker materials, and we can work this saw a lot harder on the job site. Now that we've talked about the two different types of saws, we can go through the parts that make them work. The important thing to note here is that most of the parts of a circular saw are universal, no matter which type you're talking about. So I'm going to keep this one with me. We'll go over the parts. First thing is the trigger handle. So the trigger handle is going to be the handle that we're going to use to steer this saw. This is where our control should come from. And our control means that we are going to be able to produce quality work with this tool and avoid injury and dangerous situations like binding that we'll talk about later. There's another handle on this saw. So if you're right-handed, my right hand or dominant hand is going to go on the trigger handle. My other hand is going to go on the secondary handle. As you can see here in the presentation, this is a very prominent handle. This handle is one that you would not steer this saw from. This is a backup, sort of a safety handle. If you've used or are familiar with a chainsaw, this is a handle that on a chainsaw would be one to help you prevent kickback. So if this saw kicks back, your hand is here, it's going to help prevent that saw from going into your body. The on-off switch is going to be located inside the trigger handle. This is a true on-off switch. It's not variable speed, so when you pull the trigger, the motor takes a second or two, it's going to get up to speed, then you're going to make your cut. This is a very durable switch, and it's going to have a very positive click for on and off. The fixed blade guard, this is part of the safety features of this tool. So the fixed blade guard on this tool is one that doesn't move. It's fixed. The purpose of it is to protect you from the top half of this blade. And also it's there to help channel any sawdust and other material that's being produced from the cuts away from your face and your eyes. A lot of these blade guards, these fixed blade guards, have little channels. You'll see the sawdust being thrown down and away from you while it's actually working. Now, that when it's working, it's great. When it gets clogged up, then it's going to cause problems with with the blade moving and the movable blade guard moving within it. So the next part is this movable blade guard. This is a serious safety feature on this saw that has to be working at all times. And working, you can test this very easily. There's a lever that you can move. This movable blade guard should move within the fixed blade guard very freely. It shouldn't stop anywhere in there. It also spring loaded, so at the moment that the saw is not used, it should spring over the blade to protect you from it. This a lot of times guarantees that you are not cut or injured from this blade while it's spinning. There are a lot of adjustments on a circular saw, and we need to know where they are and be able to make those adjustments at any time. Double check on those adjustments as well. So this lever here, some people get these two confused. They're similar locations. This is your blade depth adjustment lever. We're going to show you later in this presentation how to use this to tighten it or loosen it and change the depth of the blade on this saw. The base plate is the other part that when you loosen this lever, it's going to move the base plate. The function of the base plate is to make solid contact with the surface that you're cutting to set the blade at the right angle and orientation so you can make a good, solid, accurate cut. The blade depth adjustment is going to be a combination of the lever being loosened and the blade or the base plate being moved that will expose the blade. You're going to hear me say this several times. Always unplug the saw before you make any adjustments or change a blade or any work or maintenance on any power tool. Let's show here the blade depth adjustment process. So we talked about the blade depth adjustment lever. We're going to loosen it, and as I loosen that lever, now you see that the base plate, it looks like the saw is moving. In reality, it's the base plate that's hinged and moving. So we've loosened our lever. We're going to lower our saw or raise it depending on where we need it to be. And we want to be a 1/4 inch beyond our material. In this case, my intent is to cut through a 2x6, which I know is 1.5 inches deep. So ideally my depth should be set at 1.75 inches. And I can't really see what's going on up there, I'm guessing, but I'm hoping that's about 1.75 inches. I might lower it a little bit. We want to clear it. We don't want too much, but we want at least a 1/4 inch beyond the material. The last thing to do when we're talking about blade adjustment is going to be tightening up this lever, right? So once we get the proper depth, we want to make sure that lever is nice and tight. You do not want the base plate moving while you're making a cut. And if you forget to lock this down, you're going to have this uncontrolled situation which could lead to hazards. So let's do this blade depth adjustment on the other saw, the direct drive saw. Don't forget, find your cord end and make sure it is not in an outlet. There should be no power to this saw for any adjustments. First, we're going to find the lever, which in this case is in a little different place. On that saw, it's very much on the front. This one hides behind the blade guard back here. Same lever. Now when we release that lever, we can now move the saw. And as you can see, it's going to move up and down over a certain range. I'm going to lock it in about there. I'm going to guess that's about 1.75 inches. You can see better than I can. With the blade guard out of the way, you should have a good indication. If you need a 1/4 inch gauge, you can always use your pencil to see that. Now we need to lock that lever down tight. Now we're ready to go, okay, for our blade depth on the direct drive. So in this idea of finding the parts, we're setting up here for our cut, and there's a lot of things to think about before we can even make our cut. One of those things to think about is the cord strain relief and the condition of the cord and the plug. We're talking about not plugging the saw in when you're making adjustments. Another consideration is the condition of the strain relief and the cord and the plug. So the strain relief is going to help alleviate stress on this plug. If the cord takes a lot of abuse in the life and the workings of this saw. So this portion right here is going to take the most abuse, and the strain relief is there to help protect the cord. The base plate has a couple of different, I'll call them sections to it. We're going to talk about, as you can see on the presentation, in the green area, we're talking about the primary base section. And then we have the secondary or small side of this. This is the small side, this is going to be the primary side. You can always count on the weight, the main weight of this tool is always on the larger part of the base plate. So when we're setting up a cut, we always want to make sure that the larger part of the base plate is being supported. The worst thing you can have happen is to have a cut where the piece that's falling away is supporting the weight of the saw, which is then going to cause the saw to roll or fall, which could cause some damage, injury. It's going to cause a bad cut at the very least. So let's look and see how that works in real time here. Here's my direct drive saw. Weight of my motor is on the left side. I'm going to say that I'm making a cut here on this side. As I push this saw through and I make it through this cut, this piece is going to fall away, and this is my board that's supported, and my saw is not going to go anywhere. So that is one less thing that I have to worry about when I'm using this saw as far as control and safety of the saw. If I was to reverse that to this side over here, what will happen is when I make this cut, I'm going to cut this block off, and as this block falls away, this saw is going to tend to want to list or tilt to this side because the weight of the saw is no longer supported by the board. I can damage my cut that I'm trying to make. I'm trying to make a nice cut. I can make problems there. The saw can then bind. That's a safety hazard for me. And the saw can buck, and I could be in a place where it could buck into my body. So as you can see, supporting the saw, especially a heavy saw like the worm drive, and this one's no light saw either, makes a lot of sense. So it's just a matter of the setup, thinking about it for a second and putting yourself on the right side of that cut. The 0-degree guide notch is a feature on this saw that will help you with your accuracy. So if you think about a straight edge, so I'll take, let's call this cut the intended cut that I want to make. Let me move this saw out of the way. So if this is the cut that I want to make, if I have one point that I'm watching at all times, I can move that saw and it will wander. If I can watch 2 points on that saw, I have a much better chance of keeping that saw straight throughout the whole cut. So the idea of the guide notch is to add a second point to watch so that while you're trying to steer that saw, you have another point of reference. So our 0-degree guide notch on these saws they're always on the front of the base plate. As you can see here in the presentation, my dotted line is my 0-degree mark. That is going to be one point that I'm going to watch, and I'm going to try to place on my mark while I'm cutting. At the same time, I want to watch the blade as well. So I'm watching both, or the leading edge of the blade, the one that's making the furthest forward cut. This is an interesting thing to talk about with a blade, is that it's round, and that's going to affect the cut and the way you perceive the cut while you're making it. So the blade is round. Most of the material you're cutting is square or rectangular. So let's look at the geometry of that and how it affects how you can perceive and make this cut effectively. So we have a round blade, and there's a 2x6 that it's cutting through. As we cut through this piece of lumber, if we're sighting it from the top, which we always are when we're using a circular saw, we are going to assume that at this moment right here, this cut is finished. The reality is, if you look at this illustration, the red region there still has yet to been cut from the blade because of the shape of the blade. We still have to travel this far to cut through the rest of the material. So you cannot trust the view or your view from the top of this piece of lumber to determine where that cut ends. The point of this is that you have to develop a habit of following through with the cut, going further than your eye tells you you need to go when you're cutting a board or some material. And the easiest thing to do is to push through on that cut, commit to it, push it through until you see the scrap fall away. At this time, you can then stop your saw and then pull it away from the board. Now you're finished with your cut. Binding is a constant concern with a circular saw. It's not unlike reciprocating saws and many other tools. It's always a possibility, and there are things we can do to make it worse or better. So I'm going to show you a little mock-up here of a blade and my board with my cut in it. So we can assume that this cut in this blade is the cut that this blade will travel through. It's going to make this notch or slot while it's moving through the board. And it should pass through, because it's making its own space, it should pass through fairly easily. The only point of friction or difficulty is going to be at the very front of the blade, the leading edge of the blade. Binding happens when there's pinching somewhere other than at the very front of the blade. As you can see here, as I pull these two sides of this board together, I can no longer move that blade. So now you have the motor of the saw fighting the pinching action, and binding can cause damage and a lot of frustration while you're cutting. The other thing that can happen with binding, what can cause binding, is if you run the blade and you try to make a turn or change directions in the middle of your cut. A saw wants to run straight. That's what it wants to do. If we, through our control of it, try to turn to the left or to the right, we're also going to cause that binding action, which will not allow that blade to turn. That blade can buck, we can cause a lot of injury, and it definitely causes damage to the material. So your goal, your job with the saw is to prevent binding and create the longest, straightest cut that you can with the circular saw. So now that we've been through the whole process of cutting all the parts and pieces, we've gone through some of the dangers and hazards, let's go out in the shop and do this for real. Here we are out in our shop. Let's go ahead and make a simple squared cut on this 2x6 board. I've got my speed square. I'm going to mark a line. We're going to knock the end off say an inch off the end here. I got my guideline. Let's get our saw set up. I've got a direct drive saw. It's heavy on the left. That means that in this cut on this side, it's going to be supported. So before we make any adjustments to the saw, i.e. blade depth, we're going to make sure the saw's unplugged. Let's check this blade depth. And I am set good. I'm a 1/4 inch past the material. I like that. We go ahead and plug the saw in. First thing, we don't need to manually adjust the blade guard. It'll move out of the way on its own. We're going to line up our 0 guide notch, fingers off the trigger until we need to make the cut. I'm also going to align my blade as I'm looking through this saw on my guide line. So let's go ahead and do it. I'm going to back it off the material, get the saw up to full speed, and follow through with my cut. Don't forget about that blade until it stops moving, and make sure that your blade guard does cover the blade when the cut's finished, that it doesn't get pinned open. As you see here, we've got a nice square cut on this board. I followed through with it. You didn't hear any straining of the motor. It was a nice smooth cut, and I pushed past the cut. The piece fell away, and that told me that I could let off the trigger. So that is a simple squared cut on a 2x6 board. Let's make a couple of square cuts on this 2x6 board with our worm gear saw. There's a couple of differences in this saw than the other one. One, as we know from our presentation, is that this saw is heavy on the right, so I'm cutting from the other side. My heavy part's supported. The other thing about this saw is that it's going to twist or kick when we pull the trigger. I'll show you that when we plug it in. We need to make our adjustments, so I'm going to go ahead and set my blade depth. Now we can plug it in. So let me show you the action of this saw. When I'm holding this saw with both hands but with a light grip, watch when I pull the trigger. So this saw, you have to expect it to kick. The reason is because the motor is going to turn front to back. When it turns, it's a gyroscope. It's going to kick at the very beginning. So you have to expect that and know that you're not going to start your cut until that. Once it's up to speed, that's not a problem anymore. So let's go ahead and make our cut. I need to make a mark. I'm going to follow that line with my saw. We want to keep the base flat on the surface. I'm going to back it off the cut, zero mark, and watching the front of my blade. So I followed through with the cut. Let's do one more. So there you have it, a square cut on a 2x6 with a worm gear drive saw. Here we are in the shop. I'm going to make a panel cut, which is going to be a long continuous cut with the worm gear saw. First thing is setup. So I'll go ahead and mark a line, and I'm going to mark this line 5 1/4 inches in from the end. I need a point at the beginning and at the end of our panel. Now I'm going to chalk it. So there's my line to follow. I need to set the depth on my my saw here. Make sure the saw is not plugged in if you're making any adjustments. And I am way too deep for this cut. So I'm going to go ahead and raise it up about a 1/4 inch past my 1/2 inch material. So when you're making a panel cut, let me go ahead and plug this saw in. When you're making a panel cut, you're going to have support of this board. I recommend support of both pieces so that when you finish the cut, nothing falls away or nothing's tending to bind or anything. So here we have I flipped this table upside down. We're using this as sleepers. So as I cut through, I'm going to nick these boards on this table by a 1/4 inch. You're going to hear a change in the sound of the blade when I do that. I'm going to go ahead and push through it. That's okay. We're going to sacrifice those boards or the edges of those boards to make this cut. Same as cutting a piece of lumber. We're going to back the saw off and we're going to pull the trigger, get the saw up to full speed. This is a good time to talk about cord management. Here we are, and I am standing in my cords. So I'm going to stop here for a second and move these cords out of the way. I don't need tripping hazards, and I certainly don't need to be hung up on my cords while I'm making the cut. So these cords need to be out of the way. So I'm ready to go. I'm going to back this up and I'm going to follow my 0 notch and I'm going to watch the leading edge of my blade. I'll stop here real quick in the middle of this cut. At any point that you get in trouble, especially with panel cuts, the saw is fully supported as long as the blade's not moving. You can stop in that cut. The only thing is when you start up again, you'll back up enough to free the blade, get the saw up to speed, and then you can continue your cut. I wanted to talk about the body position and walking along with the saw. Make sure there's nothing in your way, no scraps, no tripping hazards, and you want to be free of the edge, and you can now follow through with that cut. Both hands on the saw, back it up a little bit, get it up to speed, and follow through. So as you see here, both pieces supported. I've made my cut. Not a bad, it's pretty straight cut. And that is a panel cut in a piece of OSB. This video is a production of Trade Skills U, all rights reserved. If you provide instruction in the construction trades and have a need for videos like these, please contact us at tradeskillsu.com.